So we have seen that we pass values to functions by substituting values for the arguments that are defined in the function. And this is effectively the same as having an implicit assignment. So when we say power xn and we call it values 3 and 5, then we have this assignment x equal to 3 and n equal to 5. It's not really there, but it's as though this code is executed by preceding this assignment there. And of course, the advantage of calling it as a function is that we don't have to specify x and n in the function definition. It comes with the call. So for different values of x and n, we'll execute the same code. So the first thing that Python allows us to do flexibly is to not go by the order. It's not that the first is x and the second is n. We can, if we don't remember the order, but we do know the values or the names assigned to them, we can actually call them by using the name of the argument. So we can even reverse the thing and say call power. I know that x is the bottom value. I know it is x to the power n, but I don't remember whether x comes first or n comes first. So I can say, okay, let's just play safe and say power it n equal to 5, x equal to 4. And this will correctly associate the value according to the name of the argument and not according to the position. Another nice feature of Python is that it allows some arguments to be left out and implicitly have default values. Recall that we had defined this type conversion function int of s, which will take a string and try to represent it as an integer if s is a valid representation of an integer. So we said that if we give it the string 76, then int would convert it to the number 76. If on the other hand we give it a string like a5, since a is not a valid number, a5 would actually generate an error. Now it turns out that int is actually not a function of one argument, but two arguments. And the second argument is the base. So we give it a string and convert it to a number in base b. And if we don't provide b, then by default b has value 10. So what is happening in the earlier int conversions is that it's as though we are saying int 76 with base 10, but since we don't provide the 10, Python has a mechanism to take the value that is not provided and substitute it with the default value 10. Now if we do provide it a value, then for instance we can even make sense of a5. If you have base 16, if you have studied base 16 ever in school, you would know that you have the digits 0 to 9, but base 16 has numbers up to 15. So the numbers beyond 9 are usually written using A, B, C, D, F. So A corresponds to what we would think of as the number 10 in base 10. So if we write A5 in base 16, then this is the 16th position and this is the ones position. So we have 16 times 10 because A is 10 plus 5. So in numeric terms, this will return 165 correctly. So how does this work in Python? So this would be how internally, if you were to write a similar function, you would write it. So you provide the arguments, and for the argument for which you want an optional default argument, you provide the value in the function definition. So what this definition says is that int takes two arguments s and b is assumed to be 10 and is hence optional. If the person omits the second argument, then it will automatically take the value 10. Otherwise, it will take the value provided by the function call. So the default value is provided in the function definition, and if that parameter is omitted, then the default value is used instead. But one thing to remember is that this default value is something that is supposed to be available when the function is defined. It cannot be something which is calculated when the function is called. So we saw various functions like quicksort and merge sort and binary search, where we were forced to pass along with the array the starting position and the ending position. Now this is fine for the intermediate calls, but when we want to actually sort a list the first time, we have to always remember to call it with 0 and the length of the list. So it would be tempting to say that we define the function as something which takes an initial array A as the first argument, and then by default takes the left boundary to be 0, which is fine, and the right boundary to be the length of A. Now the problem is that this quantity, the length of A, depends on A itself. So when the function is defined, there will be or may not be a value for A. And whatever value you have chosen for A, if there is one, that length will be taken as a default. It won't be dynamically computed each time you call puts. So this does not work. Right? So when you have default values, the default value has to be a static value which can be determined when the definition is read for the first time, not when it is executed. So here is a simple prototype. So suppose we have a function with 4 arguments a, b, c, d, and we have c as a default value 14 and d as a default value 22. Then if we have a call with just 2 arguments, then this will be associated with a and b, and so this will be interpreted as f 13, 12, and for the missing arguments c and d, you get the defaults 14 and 22. On the other hand, you might provide 3 arguments, in which case a becomes 13, b becomes 12 as before, and c becomes 16, but d is left unspecified, so it picks up the default value. So this is interpreted as f of 13, 12, 16, and the default value 22. So the thing to keep in mind is that the default values are given by position. There is no way in this function to say that 16 should be given for d and I want the default value for c. You can only drop values by position from the end. So if I have 2 default values, and if I want to only specify the second of them, it's not possible. I will have to redefine the function to reorder them. So therefore, you must make sure that when you use these default values, they come at the end and they're identified by position, and you don't mix it up and don't confuse yourself by combining these things in a random way. So the order of the arguments is important. A function definition associates a function body with a name. So it says the name f will be interpreted as a function which takes some arguments and does something. So in many ways, Python interprets this like any other assignment of a value to a name. So for instance, this value could be defined in different ways, in multiple ways, in conditional ways. So as you go along, a function can be redefined, or it can be defined in different ways depending on how the computation proceeds. Here is an example of a conditional definition. You have a condition. If it is true, you define f one way, otherwise you define f another way. So depending on which of these conditions held when this definition was executed, later on the value of f will be different. Now this is not to say that this is a desirable thing to do, because you might be confused as to what f is doing. But there are situations where you might want to write f in one way or another way depending on how the computation is proceeding, and Python does allow you to do this. Probably at an introductory stage to Python, this is not very useful, but this is useful to know that such a possibility exists. And in particular, you can go on and redefine f as you go ahead. Another thing you can do in Python, which may seem a bit strange to you, is you can take an existing function and map it to a new name. So we can define a function f, which, as we said, associates with the name f, the body of this function. At a later stage, we can say g equal to f. And what this means is now that we can also use g of abc, and it will mean the same as f of abc. So if you use g in a function, it will use exactly the same function as a. It's exactly like assigning one list to another, or one dictionary to another, or something. Now, why would you want to do this? So one useful way in which you can do this, use this facility, is to pass a function to another function. So suppose we want to apply a given function f to its argument n times. Then we can write a generic function like this called apply, which takes 3 arguments. The first is a function, okay. The second is the argument, and the third is the number of times, the repetitions. So you start with the value that you provided, and as many times as you are asked to, you keep iterating the function f. So let's look at a concrete example. So supposing we have defined a function square of x, which returns x times x. And now we can say apply square to the value 5 twice. So what this means is apply square of 5 and then square of that. So do square twice. And therefore you get 5 squared 25, 25 squared 625. So what is happening here is that square is being assigned to f, 5 is being assigned to x, and 2 is being assigned to n. So this is exactly as we said like before, like saying f is equal to square. So in this sense, being able to take a function name and assign it to another name is very useful, because it allows us to pass functions from one place to another place and execute that function inside the another function without knowing in advance what that function is. One practical use of this is to customize functions such as sort. Now, sometimes we need to sort values based on different criteria. So we might have an abstract compare function which returns -1 if the first argument is smaller, 0 if the two arguments are equal, and +1 if the first argument is bigger than the second. So when comparing strings, we may have two different ways of comparing strings in mind, and we might want to check the difference when we sort by these two different ways. So we might have one sort in which we compare strings in dictionary order. So a string like AAB will come before AB because the second position A is smaller than B. So this will result in -1 because the first argument is smaller than the second argument. If on the other hand we want to compare the strings by length, then the same argument would give us +1 because AAB has length 3 and is longer than AB. So we could write a sort function which takes a list and takes a second argument, which is how to compare elements in the list. So the sort function itself does not need to know what the elements in the list are. Whenever it's given a list of arbitrary values, it's also told how to compare them. So all it needs to do is apply this function to two values and check if the answer is -1, 0 or +1 and interpret it as less than, equal to or greater. And if you want, you can combine it with the earlier feature, which is you can give it a default function. So if you don't specify a sort function, there might be an implicit function that the sort function uses. Otherwise, it will use the comparison function that you provide. So to summarize, function definitions behave just like other assignments of values to names. You can reassign a new definition to a function. You can define it conditionally and so on. Crucially, you can use one function and make it name point to another function. And this is implicitly used when we pass functions to other functions. And in situations like sorting, you can make your sorting more flexible by passing a comparison function which is appropriate to the values being sorted.